9.3. Obtain the following primitives doing an appropriate change of variable. Okay, so we have, if you count them, there are 24 primitives. So grab a cup of coffee or tea or whatever, because this is going to take long. Okay. So for all of them, we have hints for the change of variable. Okay, but I encourage you to try to do them without looking at the hint first. Okay, see if you can think of an appropriate change of variable before looking at the hint, right? So here we have the primitive of x squared times the square root of x minus 1. Okay, so always, whenever you have a square root or cubic root, things like that, you always try to find change of variable that gets rid of the root, right? Here's like that. So this is the same as t squared x minus 1 or 2t dt is equal to dx. And now x squared is you have to write x squared in terms of t, so this is t squared plus 1 squared, right? This is x squared. So this is equal to the primitive of t squared plus 1 squared times t times 2t dt, so 2t squared dt. And now this is a polynomial expression in t. Let me go here, right? And this is what, let's see, let me expand this. This is 2 times, and then this is t to the 4th plus 2t squared plus 1 times t squared, so this is t to the 6th, t to the 4th, t squared dt. So the primitive of this is 2 times over 7 t to the 7 plus this is 4 over 5 t to the 5 plus 2 over 3 t to the cube plus c, right? And now always whenever you do a change of variable, you have to undo it. T is equal to x minus 1 to the 1/2, so this is 2/7 of 1 minus x to the 7 over 2 plus 4 over 5 times 1 minus x to the 5 over 2 plus 2 over 3 times 1 minus x to the 3 over 2 plus c. Okay, and that's your primitive. Okay, part 2. We have the primitive x squared sine of the square root of x cube, right? So again, just like I said before, always change this variable, right? The root, get rid of the root first. Okay, and so this is t squared is x cubed, 2t 2t dt is 3x squared dx, but so we have x squared here, so this is equal to sine of t, and then 2/3 of t sine of t dt. Okay, now this is one of those integrals you can do integration by parts, and if you do it, so let's do that one. Okay. So let's choose u is t, dv is sine t dt, du dt, v is minus the cosine of t, right? And so let me go down here. This is equal to minus t cosine of t, and then plus the primitive of the cosine, right? But this is the sine. Okay, so then you have, and then plus c, right? So now this is the primitive. You just have to undo the change of variables. You have the sine of the cube, the square root of x cubed minus square root of x cubed times the cosine of square root of x cubed plus the constant. This is our and this is all multiplied by 2/3. So 2/3, 2/3. Okay, that's it. Okay. take long. The primitive of the cosine of the logarithm of x. Now, what we want to get rid here is, we can try and think about this, but maybe the easiest way is to say t is the logarithm of x. That's what I would choose. And so dt is dx divided by x, but this, if t is the logarithm, then x is e to the t, right? So this is e to the t, dt is dx, right? And so this primitive is the primitive of e to the t cosine of t dt, and but we have done this before, right? E to the t cosine of t dt. This is one of those of integration by parts. You can do it. I'm not going to do it. So this is e to the t sine of t plus e to the t cosine of t divided by 2. Okay, plus a constant. Now you have to undo the change of variable. You have x sine of the logarithm, sorry, x divided by 2 sine logarithm plus the cosine of the logarithm plus c. Okay. Now part 4. So this is very similar, right? The sine of the logarithm of x. So exactly the same thing as before, right? E to the t dt is dx. So this is the e to the t sine of t dt, and this is exactly e to the t divided by 2, the sine of t minus the cosine of t plus c. And then we undo the change of variable. This is the sine of the logarithm of x minus the cosine of the logarithm of x plus c. Okay, very similar to the previous one. Okay. Now, 5. We have the primitive of the cosine squared of the logarithm of x. Now, whenever you have the cosine square or the sine square, you can either try to do it by parts, okay, the cosine squared of t or whatever. But in this case, what you need to, for me, it's very simple or very convenient to use this approximation to the so this identity. This is 1 plus the cosine of 2x divided by 2. Okay, if you don't remember this, remember that the cosine of 2x is cosine squared minus the sine squared, and 1, or the cosine of 0, is just cosine of x plus the sine of x. So if you sum the two things, you get this. Okay? And substituting here, you have 1/2, the primitive of 1/2, in other words, x divided by 2, and then you have plus the primitive of the cosine of 2 times the logarithm of x dx. So what we need to find is what's the primitive of the cosine of 2 times the logarithm of x. Okay? And wait a minute. 2 times the logarithm of x, right? And here again, we want to use this change of variable, the logarithm of x, and so we have et dt is dx, so this is equal to et, the cosine of 2t dt, and again you can do this, sorry, this is plus 1/2, right? And now you can do this primitive by parts, right? Just like before, and so you will get the result for all the primitive is, let's say this is like this. The whole primitive is x over 2 plus x over 2 cosine of 2 times the logarithm of x plus x over 5, the sine of 2 times the logarithm of x plus c. Okay? Okay, let's do part 6. primitive of the square root of x plus 1 divided by x plus 3 dx. And again, we need t is the square root of x, okay, as usual. So t squared is x, 2t dt is dx, and so this is equal to t plus 1 divided by t squared plus 3 2t dt, right? And or in other words, so this is, let's say this is 2t squared plus t divided by t squared plus 3, right? And so now we can, wait a minute, t squared plus 3, right? So now we can separate this. First we have to divide this by this, right? But this, we can see that this is t squared plus 3 and then plus t minus 3, right? So this is equal to 2 primitive of the t, or 2t, right, directly, plus, and then 2 the primitive of t minus 3 divided by t cubed plus 3. Yeah, you see what I've done before, right? So now this is one of those in which we need to separate this. So this is already in a partial fraction, simple fraction, right? But then you have the primitive of 2t divided by t squared plus 3 dt, which is going to be the logarithm of this, and then we have minus the primitive of 6 and then t squared plus 3 dt, and this is going to be an arctangent, right? So in this here, let me write it already, the logarithm of t squared plus 3, and you have minus 6 times this, right? And then, so here, let's see, this is the primitive of 1 over 3 plus t squared, right? Now we need to take common factor 1/3 out, and so we have 1 plus t squared divided by 3. So we need to change another variable, which is u is t divided by the cubic, so the square root of 3, and this is 1/3 of 1 divided by 1 plus u squared, and then the square root of 3 du is equal to dt. So this is the square root of 3 du. Now this is the square root of 3 divided by 3, 1 over the square root of 3, the arctangent of u, and so this is equal to minus 6 times the arctangent divided by the square root of 3, the arctangent of u, which is t divided by the square root of 3 plus c, okay? Now 6 divided by the square root of 3 is 2 times the square root of 3, right? And now we have to undo the change of variable, okay? So 2t is 2 the square root of x, t squared is x, so this is x plus 3, and then you have t, which is the square root of 3, of x, so this is the square root of x divided by 3. Okay, this is the primitive. Okay. Part 7, we have the primitive of x plus 1 cubed divided by the square root of 1 minus x plus 1 squared dx. And as usual, we want to say t is this square root, 1 minus x plus 1 squared. Okay, always get rid of the square root, or in other words, that t is equal to 1 minus x plus 1 squared. 2t dt is equal to minus 2 x plus 1 dx. Okay, now we substitute here, so we have well, 2 and 2 go out, you have a minus sign here, and so t dt is equal to x plus 1 dx. So you have an x plus 1 cube, so you have x plus 1 squared and then t dt divided by t. So t and t go out, and you have to write x plus 1 in terms of t, which is t squared minus 1 is equal to minus x plus 1 squared. So this is equal to the primitive of t squared minus 1 dt. So this is t cubed divided by 3 minus t plus a constant, and then we undo the change of variable. This is 1/3 of 1 minus x plus 1 squared to the 1/3. Sorry, not to the 2, to 3 over 2, sorry. To the 3 over 2 minus the square root of 1 minus x plus 1 squared plus c. And that's it. Let's go for part 8. Part 8. You have the primitive of x cubed divided by 1 plus x squared cube dx. So yeah, we have a power here of 1 plus x squared. You could maybe try to do this without a change of variable, but my recommendation is to go straight for this. The t is going to be 1 plus x squared, right? And now, so dt is 2x dx, and here we have, and see that x squared is t minus 1. So you have x squared times x, t minus 1, times x dx, so times dt, divided by 2, because there's a 2 here, and then you have t cubed here, right? And now what you have to do is expand this in partial fractions, right? So this is going to be, well, not exactly, you already have that, right? So don't worry about it. So this is 1/2 t divided by t cubed is 1 over t squared minus 1/2 of 1 over t cubed. Now this is minus 1 over 2 times 1 over t, and this is plus, and then you have the primitive of this is 1/2 of this, so 1/4 of 1 over t squared plus c. Now if you undo the change of variable, you have 1 over 2 times 1 plus x squared plus 1/4 of 1 plus x squared squared plus c. That is the primitive. Okay. In part 9, okay, we're already 1/3 of the way up. This is the primitive of dx divided by 2 plus x, the square root of 1 plus x. So t is going to be the square root of 1 plus x. T squared is 1 plus x. And 2t dt is equal to dx, right? Now 2 plus x is obviously t squared plus 1, right? Yeah, 1 here, right? So now we have 2t dt divided by t, and then t squared plus 1, right? T and t go away, so you have 2 times the arctangent of t, but t is just the square root of 1 plus x squared, sorry, plus x, c. Okay, that was easy. X, you have dx over 1 plus the cubic root of 1 minus x dx. Obviously t cubed has to be equal to 1 minus x, right? We want to get rid of the root. 3t squared dt is minus dx, so if we substitute here, we have, I wrote dx twice, sorry. This is minus 3 times t squared over 1 plus t dt, so we have to divide t squared by t plus 1, because this has greater degree, so this is t minus t minus minus t squared minus t. We have minus t minus 1, and then plus t plus 1, 1. Okay, so the result of this is minus 3, and then you have the primitive of t minus 1 dt plus the primitive of 1 over 1 plus t dt. Now the first one is minus 3 over 2 t minus 1 squared plus, and then the logarithm of, minus 3 times the logarithm. Minus 3 times the logarithm of the absolute value of 1 plus 3 plus t. Now we undo the change of variable, right? T is the cubic root of this minus 1, so minus 3 over 2 times the cubic root of 1 minus x minus 1 squared minus 3 times the logarithm of 1 plus the cubic root of 1 minus x plus c. Okay, this is the primitive. Okay, one of those. Okay. Now 11. You have e to the 4x divided by e to the 2x plus 2e to the x plus 2 dx. Now obviously t is e to the x, so this is t to the 4, t squared, whatever, right? Dt is e to the x dx, so you get, this is e to the 3x times e to the x, so you have t cubed dt divided by t squared plus 2t plus 2, and in case this is relevant for later, this is going to be t plus 1 squared plus 1, right? So as before, we have to divide t cubed by this, t squared plus 2t plus 2. So let's see, this is t, right? And then we have minus t cubed minus 2t squared minus 2t minus 2t, so we have 2t squared plus plus 4t plus 4, so the remainder is 4t minus 2t plus 4. Okay, so this is going to be equal to t minus 2, primitive of this, plus the primitive of 2t plus 4 divided by t plus 1 squared plus 1 dt. Okay. Now this is one of those that doesn't have real roots, so the first one is t minus 2 squared divided by 2, and then we can separate this into the one that's going to be the logarithm, right? So this has to be the derivative of t plus 1 squared here, which is going to be 2t plus 1 or 2t plus 2, and then a 2 here, right? Instead 2 plus 2, 4. So you have 2t plus 1 divided by 1 plus t plus 1 squared dt plus, and then 2 times 1 over 1 plus t plus 1 squared, right? And now this is the logarithm of 1 plus t plus 1 squared, and this is the arctangent of t plus 1. And so if we undo the change of variable, you have e to the x minus 2 squared over 2 plus the logarithm of e to the x plus 1, is the logarithm of 1 plus e to the x plus 1 squared. Okay, and this is going to be the same as this, and plus 2 times the arctangent of e to the x plus 1 plus c. Okay. Now we have part 12, the primitive of the square root of e to the 2x minus 1. Now, as always, we need to get rid of the square root, so t is the square root of e to the 2x minus 1, or in other words, t squared is e to the 2x minus 1. 2t dt is 2 e to the 2x dx, right? And now e to the 2x is t squared plus 1, right? So now let's see, this is equal to 2 and 2 go out, so you have t dt, t divided by t squared plus 1, right, dt, this is dx, and then times 1 over this 1 over t, so t and t go out, and this is just the arctangent of t plus c, or in other words the arctangent of the square root of e to the 2x minus 1 plus c. Okay. Now part 13. Primitive of the square root of e to the x minus 1. Now again, t squared is e to the x minus 1, 2t dt is e to the x dx, so dx is 2t divided by e to the x dt, but e to the x is again t squared plus 1, t squared plus 1 dt, right? And so the primitive of this is what? The primitive of t times all of this, so 2t squared divided by t squared plus 1 dt, right? And now let's see, so this is, we have to write 2t squared plus 2, right, because now we have the same as in the denominator, minus 2, right? So this is the primitive of 2 dt minus 2 over t squared plus 1 dt, and this is 2t minus 2 the arctangent of t plus c, which is 2 times the square root of e to the x minus 1 minus 2 the arctangent of the square root of e to the x minus 1 plus c. That's the integral. Okay. This is the primitive of the sine squared of x cosine to the 5 of x divided by the tangent cube of x dx. Okay, so let's see. Let's first of all simplify things, right? So we have the tangent is the sine cube divided by the cosine cube, right? Cosine cube goes multiplying, so this is the cosine to the 8th, right? And then you have the sine cube, the sine in the denominator, right? So can we find one proper change of variable here? You could try either the cosine or the sine, okay? So let's try the cosine, okay? So let's see, if t is the cosine, then dt is minus the sine of x dx, right? So if we go here, this is going to be equal to t to the 8th divided by the square root of, wait a minute, yeah, so this is minus, right? And then you get dx is equal to dt divided by sine, so you have the sine squared, so the sine squared is, if t is the cosine, you have 1 minus t squared is the sine squared, right? So this is 1 minus t squared dt, right? Is this correct? Yes. So now we can change the sign here, so this is t to the 8 divided by t squared minus 1, and this is going to be, well, first of all, divide t to the 8 by let me write this, because this is going to be long. T to the 8, t squared minus 1, so you have t to the 6, right? You have minus t to the 8 plus t to the 6. Now you have plus t to the 4, So you have minus t to the 6 plus t to the 4, and then plus t squared. You have t to the 4 minus, sorry, plus t squared plus 1. Okay, so you have minus t squared plus 1. So this is the same as the primitive of t to the 6 plus t to the 4th plus t squared plus 1, right? And then dt plus the primitive of 1 over t squared minus 1. Okay? So let me erase things. All of this. So let me go back here. You have t to the 7 over 7 plus t to the 5 over 5 plus t cubed over 3 plus t, and then this is going to be a over t minus 1 dt plus b over t plus 1 dt, right? And we know that a times t plus 1 and plus b times t minus 1 have to be 1. Okay? Now if we solve this, this is 1/2 here and minus 1/2. So this is the primitive of this is 1/2 the logarithm of t minus 1 minus 1/2 the logarithm of t plus 1 plus c. Okay, and now we can undo the change of variable. Remember that t was equal to the cosine, so you have cosine to the 7 plus cosine to the 5 plus cosine cube over cube plus cosine of x plus, and then 1/2 of the logarithm, and then we have the cosine of x minus 1 divided by the cosine of x plus 1. Okay, and yeah, because this is going to be always you can rewrite it like this. Wait a minute. Yeah, no, this is correct. Well, yeah, this is the absolute value of this, right? So you can write the absolute value of 1 minus the cosine of x divided by 1 plus the cosine of x. Okay, that's the primitive. Okay. 15. The primitive of 3 plus the square root of 2x plus 5. Now here obviously the change of variable is the square root of 2x plus 5, but this is not going to work exactly, so we may need these 3. Okay, so 3 plus the square root of 2x plus 5 dt is the derivative of this, which is 2 divided by 2 the square root of 2x plus 5, and then the x, right? So you have this and this go away, and then the square root of this is t minus 3, right? So here you have what? T minus 3 dt, right? This times this equals dx divided by t. And this is, you go here, the primitive of 1 minus 3 over t dt, or in other words, t minus 3 times the logarithm of the absolute value of t. If you undo the change of variable, you have 3 plus the square root of 2x plus 5 minus 3 times the logarithm of 3 plus the square root of 2x plus 5 plus c. Okay? Part 16. The square root of x minus 1 divided by x plus 1 dx. Well, let's go for all. So t squared is x minus 1 divided by x plus 1. Okay, and now let's see. This is 2t dt, right? And the derivative of this is x plus 1 squared x plus 1 and then minus x minus 1, right? So you have 2 divided by x plus 1 squared. 2 and 2 go away, so you have t x plus 1 squared dt equals dx. So this is dx, right? So now the question is how to express t in terms of x, right? Or sorry, x in terms of t. So you have to solve this equation. So you have t squared x plus t squared equals x minus 1. So this is, let's say, t squared minus 1 x equals minus 1 minus t squared. So in other words, you have x is equal to t squared plus 1 divided by 1 minus t squared, or let me write it here, 1 plus t squared divided by 1 minus t squared. This is what you have, right? And so now we need to say, well, we have x plus 1, let's say, so this is equal to the primitive of t, and then t squared times x plus 1 squared. So you have x plus 1 is 1 plus t squared plus 1, so let's say 1 minus t squared divided by 1 minus t squared. All of this squared, but this is t squared and t squared will go away, so this is 2 squared 4 divided by 1 minus t squared squared. Okay, this is the primitive that we want. Okay, so let me erase all of this. We have, let me write here, t squared equals x minus 1 divided by x plus 1. And now we have this thing, right? Now, well, this is the same as t squared minus 1 squared, because this is squared doesn't change. So this is equal to 4, and then we have t squared divided by t, right? So here we have t plus 1 squared times t minus 1 squared. So we can simplify this into, let's see, this is 4 times, right? And then we have the primitive, or, well, if you include the 4 here, right? If you, let's see, yeah, 4, this is a divided by t plus 1 dt plus b divided by t plus 1 squared dt plus c divided by t minus 1 plus d divided by t minus 1 squared. Okay, now again, you know how to solve this thing. If you solve this and multiply by 4, you would get 1/4 everywhere. You have minus 1 over t plus 1 dt plus 1 over t plus 1 squared dt plus 1 over t minus 1 dt plus 1 over t minus 1 squared dt. And we know how to compute all of this. So you have the logarithm of t minus 1 divided by the logarithm of t plus 1 minus 1 over t plus 1 minus 1 over t minus 1 plus c. Okay, and then you can undo the change of variable here by writing t equals the square root of x minus 1 x plus 1. Okay, so you can work with this if you want, and doing the change of variable. Okay, part 17. The primitive of the square root of x plus 1 dx. And again, we want t to be the square root of the square root of x plus 1. Or in other words, t squared is the square root of x plus 1. 2t dt is 1 over 2 the square root of t dx. And the square root of x is just t squared minus 1. So you have 4t times t squared minus 1 dt is going to be equal to dx. So this is 4t squared minus 1 dt. Okay, and now this is easy, right? Because we have 4t t to the 4, so this is 4t to the 5 divided by 5, and then minus 4/3 of t cubed plus c. Now if you undo the change of variable, this is 4/5 of the square root of x plus 1 to the 5/2 minus 4/3 times the square root of x plus 1 to the 3/2 plus c. Okay. (18) The primitive of the square root of x plus 2 divided by 1 plus the square root of x plus 2 dx. Now it seems obvious that t has to be this, so t squared is x plus 2, 2t dt is dx. So here we have, let's say this is t divided by 1 plus t times 2t dt, or in other words 2t squared 1 plus t dt. And as usual, we need to divide t squared by t plus 1, so this is t minus t squared minus t, and then so minus 1, right? So plus t plus 1. So the remainder is 1. This is equal to t minus 1 dt. Sorry, 2t then. 2 times the primitive of t minus 1 dt plus, or sorry, minus 2 times 1 over 1 plus t dt. And now this is 2t minus 1 squared divided by 2, or in other words, t minus 1 squared minus 2, the logarithm of 1 plus t plus c. Now, so this is t minus 1, the square root of x plus 2 minus 1 squared minus 2 times the logarithm of 1 plus the square root of x plus 2 plus c. Okay? Okay, so let's see part 19. Almost there. The square root of 2 plus e to the x. Wait a minute. 2 plus e to the x dx. And as usual, this is the square root of t is equal to the square root of 2 plus t to the e to the x. So 2t dt is equal to e to the x dx, but e to the x is just t squared minus 2. So here you get 2t squared divided by t squared minus 2 dt. Right, so this is, we can say this is 2t squared minus 4 plus 4. So you have 2, right, 2t, and then plus 4 times the primitive of dt over t squared minus 2. Right, and is this correct? Yes. Yes. So now we have to expand this. This is equal to 2t plus, and then 4 times the primitive of a t minus the square root of 2 plus 4 times b t plus the square root of 2 dt, right? And as usual, you can expand this and you'll see that you get, so you get a times t plus the square root of 2 plus b times t minus the square root of 2 equals 1, or 4 if you want, right? So if t equals the square root of 2, then you have 2 times the square root of 2a is 1, so a is 1 over 2 divided by the square root of 2 times 4 is 2 divided by the square root of 2, or in other words, the square root of 2, right? So this is the square root of 2, okay? And then if t is minus the square root of 2, this goes away, so you have b minus 2 times the square root of 2 is b equals 1, so b is minus the square root of 2. Now this is 2t plus the square root of 2, the logarithm of t minus the square root of 2 minus the square root of 2, the logarithm of t plus the square root of 2 plus c, right? And then so the t was 2, the square root of 2 plus e to the x, and then you have plus the square root of 2 and then the logarithm of the square root of 2 plus e to the x minus the square root of 2 divided by the square root of 2 plus e to the x plus the square root of 2. Okay? Plus c. Okay? Okay. Let's go for 20. Only 5 more to go. Okay. Sine of x plus 3 cosine of x divided by the sine of x plus 2 times the cosine of x. Okay, so this is one of those in which you need to make the change of variable the tangent of x over 2, and this will change this expression into a rational function in t, right? But the hint says to use tangent of x, but if you use tangent of x over 2, you will find similar results. Okay, so let's see. If t is the tangent of x, right? Then let's say we can say that wait a minute. Okay, so why is this that the hint is the tangent? Because here you have the sine of x plus the 2 times the cosine, right? So this is dx plus the cosine of x divided by the sine plus 2 times the cosine, right? Now, so this is x plus, and then if you divide both the numerator and the numerator by the cosine, you have the tangent plus 2. So now the only important thing that changes here is the tangent, right? So this is dt is 1 plus tangent squared of x times dx. So this is x plus the primitive of, and then we have 1 plus t squared, right? It's dt divided by 1 plus t squared times 2 plus t. And now we can solve this easily, right, by expanding it into the two fractions, the two partial fractions, right? So you have a divided by t squared plus 1 dt, at plus b, and then you have c divided by t plus 2, right? If you do this, you will see that you get minus t plus 2 divided by a fifth, and you have a fifth of 1 here. Okay. So again, in order to write this, let's 1/5 of minus t plus 2, so let's say minus, this is minus 1/5 of t minus 2 t squared plus 1. Well, we want to separate this into two integrals primitives. One is the logarithm of this, and one is going to be the arctangent, right? Now the derivative of this is 2, so you have to multiply and divide by 2. So 1 over 10 times 2 t minus 4, and so you have minus 1 over 10, the primitive of this, which is the logarithm of 1 plus t squared, and then you have minus 4, so this is plus 2 over 5, right, of the arctangent of t. Okay, if I'm correct. And so and then you have this, okay, which is the logarithm of 2 plus is this correct? Yes, right. And so this is the logarithm of t plus 2, right? So let me write this in it. So you have x minus 1 over 10 times the logarithm of 1 plus, and t is the tangent, so the tangent squared of x, plus 2 over 5 the arctangent of t, which is the tangent of x, but this is the same as x, right? So 2 over 5 times x plus 5 over 5 is 7 over 5, okay? 7 over 5 times x, and then the last one is 1 over 5 the logarithm of t plus 2, so 2 plus the tangent of x plus c. Okay, this is the final primitive. Now let's do 21. The sine of x plus 3 times the cosine divided by the sine, cosine plus 2 times the sine dx. Okay, now this is one in which you definitely have to apply the change of variable where, wait a minute, yes. So there's no way to simplify this easily, right? So here you have to go to this change of variable t equals the tangent of x over 2. Okay, whenever you have this kind of rational function of sines and cosines, you can use this. And if you don't remember how from this you get to the sine and the cosine, you can remember that the sine of x is going to be 2t equals 1 plus t squared. Cosine of x is 1 minus t squared over 1 plus t squared, and then dx is equal to 2 dt over 1 plus t squared. Okay, now the way to do this is to remember that the tangent squared of x over 2 is going to be equal to 1 plus the tangent squared is going to be 1 over the cosine squared of x over 2, right? And from this you can go this is t squared, right? So the cosine squared of x over 2 is going to be 1 over 1 plus t squared. And then remember that the cosine squared of x over 2 is equal to 1 plus the cosine of 2x, or in other words x divided by 2, right? And so let's see, so this is going to be cosine squared is 1 over 1 plus t squared times 2, right? So this is 1 plus the cosine of x. The cosine of x is 1 minus this, so it's 1 plus t squared minus 2. Is this correct? No, yes, sorry. So this is 2 minus 1 minus t squared over 1 plus t squared. So you have 1 minus t squared, which is this thing. Now once you have the cosine, you can get the sine by saying we know that the cosine squared plus the sine squared is 1, so the sine is the square root of 1 minus the cosine squared, and so the cosine squared is going to be minus, and so you have 1 minus t squared squared 1 plus t squared squared. So you have the sine of x is you have the square root of 1 plus t squared squared minus 1 minus t squared squared, all of that divided by 1 plus t squared. And if you do this, you get the result will be 4t squared here. Everything else cancel out, so the square root of 4t squared is 2t. Okay, that's how you get this change of variable if you don't remember. Okay, and then dt is 1 plus the tangent squared of x over 2 dx, but this is t squared. Okay, so that's divided by 1/2, right? Because this derivative of this. So you have 2 dt divided by 1 plus t squared is dx, which is this. Okay, so this is just how to obtain all of these rules if you don't remember them from this. Okay, now so now let's apply this, right? So we have the sine of x, right? 2t over 1 plus t squared plus 3 times 1 minus t squared with the same denominator, right? Divided by the sine of x, 2t 1 minus t squared divided by 1 plus t squared squared, and then plus 2 times the sine, so this is 4t, and then 1 plus t squared, all of this divided by 1 plus t squared squared, right? And then times dx, so you have 2 times dt divided by 1 plus t squared. Now you can see here, right, this and this go away, so you have the primitive of, and so you have 4t plus 6 1 minus t squared divided by 2t minus 2t cubed plus 4t plus 4t cubed dt. Okay, let me simplify that a bit. So you have, let's see, this is 4t plus 6 minus 6t squared, if I'm correct, right? And then you have here, you have 6t plus 2t cubed, right? So you can take a common factor 2t, you have 3 plus 2, 3 plus t squared, right? That's it. So let me go back and rewrite this here. So we have, this is equal to the primitive of minus 6t squared plus 4t plus 6 divided by 2t t squared plus 3 dt, right? And so now we have to separate this into partial fractions, right? So it's always going to be this 1/2, sorry, of everything. You can divide everything by 2. So this is, let's see, this is minus 3t squared plus 2t plus 3, and then the 2 goes away. Yep. And is this correct? Yep. And so now we have to separate this into a divided by t plus, and then b divided by t squared plus bt plus c, right? So let's see how we do it. Let's see, we have a times t cubed plus 3 plus bt squared plus ct is equal to this. Okay, let's call this minus 3t squared plus 2t plus 3. If t equals 0, then we have 3 times a equals 3, so a is 1. Now if t equals 1, for instance, you have 4a, or 4, plus b plus c equals minus 3 plus 2, minus 3 minus, so this is 2, right? So b plus c is minus 2. And then you have t equals minus 1, you have always again 4 plus b minus c equals minus 3 minus 2 minus 5 plus 3, so it's minus 2, right? So you have b plus c is minus 2, b minus c is minus 6. So if you sum these two, you get b is equal to minus 4, and if you subtract, you have c equals 4, 2, right? Yeah, okay. So then let's say this is 1 over t, and then you have 2 minus 4t. Okay? Okay. Now this is going to be the logarithm of the absolute value of t. Obviously Then you have t squared plus 3. So let me write this into two different primitives. This is 2 times 2t divided by t squared plus 3. So this is the logarithm of this, and then you have plus 2 times 1 over 3 plus t squared dt. And now we have to work with this a bit. Let me go here. So we have 1 over, so we have 1/3 of 1 plus t squared divided by 3. So if we write u is t divided by the cubic root, sorry, the square root of 3, you get 1/3 of 1 over 1 plus u squared, and then du is square root of 3. Wait a minute, du is this, wait a minute, so you have u is t divided by the square root of 3, so du is dt, right? That's it. So the square root of 3 du, and so this is going to be the square root of 3 divided by 3, or 1 over the square root of 3, the arctangent of u, which is t divided by the cubic root, so the square root of 3 plus t. So this is going to be the logarithm of the absolute value of t minus 2 times the logarithm of t squared plus 3 plus 2 divided by the the square root of 3 of the arctangent of t, which is t divided by the square root of 3. Okay, and then you can undo this change of variables. So t is going to be the tangent of x plus 2, sorry, over 2, the tangent square of x plus over 2 plus 3, and this is the tangent of x squared over 2, x over 2 over the square root of 3. Okay, so you can see how this kind of primitives are a pain to do, but with this change of variable, you can always get them right. Okay, it's going to be longer sometimes, but it's always doable. Part 22. This is the square root of 1 plus cubic root of, the cubic root of x divided by the cubic root of x. Obviously, we want to get rid of this, so this is t is going to be the square root of 1 plus the cubic root of x. Now t squared is 1 plus the cubic root of x, or if you want, x to the 1/3. 2t dt is 1/3 of x to the minus 2/3 dx. Now x is t squared minus 1 cubed, right? So this is going to be 2t dt times 3 is 6. Okay, and let's see. Well, this is equal, 60 is equal to dx divided by the square root of x squared. So it is the cubic root of x squared, but here we have a cubic root of x, and so we can multiply it here, the cubic root of x. Now the cubic root of x is exactly t squared minus 1. So now this is equal to t, and then dx over this is equal to t squared minus 1 times 6 times t dt. Right, now we have all of that. Okay, and now this is just a polynomial, right? This is 6t to the 4th minus 6t squared dt. And so this is 6t to the 5 divided by 5 minus 2t to the cube, right? Plus c. Now, and then you just undo the change of variable. This is 1 plus the cubic root of x to the 5 over 2 minus 2, 1 plus the cubic root of x to the 3 over 2 plus c. Okay, all of these with roots are always the same, as you can see, right? Okay, 23, we're almost there. The primitive of dx over x plus 1, the cubic root of x plus 2. Now obviously t cubed we want to be equal to x plus 2. So 3t squared dt is the x, and let's say x plus 1 is just t cubed minus 1, right? Is equal to x plus 1. So we have dx is 3t squared dt divided by t cubed minus 1 and then times t. So t and t cancel out, so your 3t divided by t cubed minus 1 dt. And now we have to find the roots for t cubed minus 1. We have done this several times before, so we already know that t cubed minus 1 is equal to t minus 1 times t squared plus t plus 1. So we want to express this as a over t minus 1 dt plus, and then we have bt plus c over t squared plus t plus 1 dt, right? Now if you do that, you will find that you get, let me see, this is 1 over t minus 1 dt plus t divided by t squared plus t plus 1 dt plus 1, sorry, minus 1. Sorry, this is minus t plus 1. Okay, now this is, again, this is obviously the logarithm of the absolute value of t plus 1, and then we need to worry about this. As usual, we need to, this is minus, and then we have t minus 1 right here, t squared plus t plus 1 dt, right? Now if we want to, well, first of all, get rid of this, we multiply and divide by 2, right? You have 2t minus 2, and then this is the derivative of this is 2t plus 1, so 2t plus 1 minus 3 actually, right? Let me write it here, correct. 2t plus 1 minus 3, right? So now we have minus 1/2 of the primitive of this, which is the logarithm of t squared plus t plus 1, sorry, right? And then we have plus 3 over 2, 1 over t squared plus t plus 1 dt. And in order to do this, we need to complete the square, right, as usual. And so let me write everything here. So this is minus 1/2 of the logarithm of the absolute value of this, right? And then we have plus 3 over 2, and then the primitive of 1 over t squared plus t plus 1 dt, right? Okay, and then let's see, so yeah, here we have to, this is 3 over 2, and we have to complete the square, right? So t squared plus t plus what is it, right? That you have t plus something squared, right? This is t plus whatever plus 2, right? So this is 1/2, so we have 1 over 4, and this is t plus 1/2 squared, right? In order to get to 1, we have to add 3 over 4, right? So this is equal to 3 over 4 plus t plus 1 over 2 squared. Now we take a common factor 3/4, so this is equal to 2, right? Because you get divided by 3/4, and this is 1 over 1 plus t plus 1 over 2 divided by 3 over 4 squared, right? Now we have to make a change of variable here. U is, we've done this one before, right? So this is 2t plus 1/2, or if you want t, 2t plus 1, right? You multiply this by 4 and then divide it by the square root of 3. So du is 2 divided by the square root of 3 dt. Yeah. So now we have this is equal to the square root of 3, yeah, that multiplies this, the integral primitive of 1 du, right? And then with this, we have the square root of 3, the arctangent of u, which is 2t plus 1 divided by the square root of 3 plus c. Okay, this is what you get here. Okay, and then you can undo the change of variable, remembering that t is the cubic root of x plus 2, so you can write it here in all these words, and you're done. Okay, so this is the end of this integral. Okay, and then we have 24 e to the x minus 4 e to the minus x. Okay, and then here what we want is obviously t is e to the x, so dt is e to the x dx, or in other words, so dt is so dt divided by t is dx. So this is equal to dt divided by t squared minus 4, and so this is equal exactly the same as t plus 2 times t minus 2, so you could separate them in t minus 2 dt plus t plus 2 dt, and if you do that, you will get 1/4 of the logarithm of t minus 2 minus 1/4 of the logarithm of t plus 2 plus the constant. Okay, in other words, 1/4 of the logarithm of e to the x minus 2 divided by e to the x plus 2 plus a constant. And that's the last primitive of this exercise.